So Dean, tell me about the UGMO system and how you use it to save irrigation water.
You bet. Well, what we do is, first off, UGMO stands for Underground Monitoring. It's the only wireless sensor technology available for the irrigation and outdoor watering platform. And what we do is we have this base unit, which is hardwired into clients' current irrigation timers. And then we have it paired and married to the sensors, which are wireless. We use a golf cup cutter. We bury the sensors completely underground in relative areas that measure the moisture and temperature of the soil. We take into account microclimates, trees, buildings. We take into account slopes, shades, all of the things that affect how water is being transferred into the soil and being absorbed into the soil. And we also program the sensors to soil type, from a sand-based soil all the way down to a hard caliche clay soil, where we have a lot more evaporation than we have absorption into the soil. So all of that is taken into account, married with the client's current irrigation system, and implemented to then micromanage the irrigation system that the client has. So what we're doing is, because of the soil type, we're now regulating how much water is being consumed, and that in itself will save money and provide a healthier root base with consistent water levels in the moisture in the soil.
I understand that when you put these systems in and you bury the sensors, you have a very detailed way of finding them. Could you talk just a little bit about that? Or?
Absolutely. What we do is basically provide an as-built, a document that shows where the sensors are buried to approximate locations. So first way to find the sensors, we use a little yellow wisp that's buried just above the soil line where the sensor is actually physically located. The second thing we do is we photograph where the sensor is located, and we'll measure to fixed points, sidewalks, roadways, pavers, whatever that fixed point is. And then the final way to find the sensor is to use a metal detector. In that as-built, the client basically has an aerial of their property. Little dots mark where the sensors are located with arrows pointing where the measurements are, with a verbal description as well.
Mm-hmm. And since these are battery-powered instruments that are buried in the ground, how long do you typically get on a battery? What's the life?
It's two AA batteries that are housed right here. The lab life is basically 10 years. Field life, more realistic life, is 3 to 5 years for battery life, because the system is asleep for 9 minutes, and on the 10th minute it spurts out its data, no more than 400 megahertz or the same frequency as a garage door opener, and then it goes to sleep. So it's very minimal impact on the batteries.
Okay. And maybe if you would, just a little bit about what type of facilities you use these in and what kind of savings you're seeing.
It's across the board. It's pretty scalable product in regards to how we manage the turf area. So we're in anything from a professional baseball field like the San Francisco Giants training facility in Scottsdale, Arizona, to a professional HOA, which is Cotton Center Boulevard, where we have 6 turf areas and 3 points of entry, to schools, to industrial parks, to office parks, and also cities, parks, and recreation type facilities. We're seeing anywhere from a 20 to 45% reduction in water consumption. In the exact example as far as dollars go, for the city of Phoenix, we're in the Sky Harbor Airport. The first month that we were in, we reduced watering by 450,000 gallons, which is in Arizona $1,000 per every 300,000 gallons of water. So we saved them a little over $1,500 in this first month of being in use.
Good.